Hello grade 12s, welcome to my channel. Let us continue with this document. So these are the NBT practice problems. I'm sure you've enjoyed the previous videos and especially the very previous video, the last one of this type. You must have seen some very interesting questions that we went through, hoping that folks, you are not going to cram these by any means. Believe me, don't do it, but rather try to see the thought behind every action that we do and how to unentangle oneself when found in a corner of entanglement. It happens sometimes what is known or what is commonly done does not work. So a thought outside that little box sometimes saves the day. So let's hope you're going to continue to learn through these videos, and please do interact in the comment section if you experience any issues with what I'm doing, especially issues of not understanding. Please do voice out your frustrations or your concerns. Now, question 21 says, in the diagram, the Venn diagram shows events C and D. The numbers shown indicate the number of elements, meaning 12 means 12 elements. Okay, it's not the probability basically. And C and D are independent events. Okay, so what do we know about independent events? We know that the probability of C intersect D is going to be the probability of C multiplied by the probability of D. Okay. So that's essentially what we know, okay, can be done. This, sometimes we can even say the number of C intersect D could also be looked at as the number of C. Am I right? I think so. If we multiply by the common denominator throughout, this is possible. It is truly possible. So this is the rule. But of course, refrain from, some silly deductions. They may sound proper, but sometimes may not necessarily be true. But I think it is true. Because, these all have the same denominator. So if you multiply by it throughout, it simply goes away. So this rule stands true. All right, so the question says x times y is equal to. Now if we look at x is the intersection between C and D, whereas y is what is not part of C and D. Now under which circumstances would we have ourselves multiplying these? Well, so obviously this tells us that we're going to have to look through the product rule, because there is a product, so maybe there's a very good chance we can do that. So we know, folks, that the probability of C intersect D should be the probability of C multiplied by the probability of D, because these two events are independent. Now, the number is x. The total is a bit strange. It's going to be all of these, 12 plus x plus 6 plus y. So we're going to get 18 plus x plus y as our total. This is equal to C. It's going to be 12 plus x over 18 plus x plus y. This is multiplied by D. So this is x plus 6 all over 18 plus x plus y. Of course, now we've got an algebraic issue, but the nice thing is that we've got a common denominator. But let's first simplify this before we think about that. So we've got x all over 18 plus x plus y equals, we're going to have 12. In fact, let's start with x. Addition is commutative. multiplied by x plus 6, all divided by, we're going to have 18 plus x plus y squared. Right, so now we've got things that we can do, right? What I'm thinking we need to do is to just multiply by this denominator so that we can just get stuff under control. So if we multiply by 18 plus x plus y, what do we get? We get x over 1 is equal to, it's going to be x plus 12 into x plus 6, all divided by, this one takes the square, so we end up with just 18 plus x plus y. Right. So sometimes choose the best approach or whichever you can handle. So now we can cross multiply here. So if we cross multiply, we're going to get 18x plus x squared plus xy equal to, this becomes x squared plus 12x plus 6x becomes 18x. 12 times 6 becomes 72. The nice thing is that 18x and 18x do the number on each other. The x squared does the number to the x squared. Guess what? xy becomes 72. So therefore our answer is option C. Okay, so a bit of understanding of probability and also knowing how to work functions became our absolution here. All right, so let's look through question 22. So question 22 says the expression 2x cubed plus mx squared minus 3x plus n is divisible by x squared minus x minus 2. So what do we know, folks? This tells us that essentially this x squared minus x minus 2 equal to 0 is a factor. Right, so that's factor theorem. Okay, so this is cool. So obviously what we're going to do there, we know that x squared minus x minus 2 equal to 0 must be a factor. Of 2x cubed plus mx squared minus 3x plus n. Okay. Now what does this imply? We can factorize this even further. So this gives us x minus 2 plus 1. So this tells us that x is minus 1 or x is 2. So this means when we substitute these values into our cubic equation, it should give us 0. So that's the understanding. Okay, so this now asks what would be the value of m plus n. Again, we can see that when would we find ourselves adding these two? Obviously, through some sort of a simultaneous equation. Okay, so we know, folks, that if this is the case, this then tells us that 2 into minus 1 cubed plus m into minus 1 squared minus 3 into minus 1 plus n must be equal to 0. So if we plug that minus 1 into that expression, Seeing that this came from a factor, it means it leaves no remainder. The remainder is 0. Okay, so let's see. This is going to be minus 2 plus m plus 3 plus n is equal to 0. So we end up with m plus n is equal to, this is going to be 1. When we transpose, we get minus 1. Problem solved. Okay, just one of these. All right, so the answer there is option C. Okay, so we can say, therefore, we walk away with option C. So can you see, sometimes, folks, just one move gives us what we want. But at times it's not that simple, okay? Because let's say you started with the 2, what happens? Of course, we could look for the value of of m, and also look for the value of n, and then add them directly using simultaneous equations to find the 2 variables. It's still possible. But sometimes, you know, one approach might just get you home in no time. All right, so that's it, folks. We are done with this question. It wasn't as bad as it wanted to look. So let's look at question 23. So question 23 says, if m squared minus n squared is equal to 2021, and 47 into m plus n to the minus 1 is equal to 1. So what's the value of m minus n? Again, this is probably one of those questions where a bit of problem solving can be done. Okay, let's have a look at this. What is given? So we've got m squared minus n squared, a difference of 2 squares, is equal to 20, 21. Okay, now I'm thinking, could I write this 2021 as a difference of 2 squares? Let's see. This implies that m squared minus n squared is equal to, now 2021 is 2025 minus 4, right? I know 4 is a perfect square, but is 2025 a perfect square? This is somewhat a multiple of 5. Let's find out what's cooking here. Now, I know that I'm trying to think. Is 25 squared 625? Let's check. So 25 times 25, what do we get? This is 5. We carry the 2. This is 10, then this is 12. Right. That's it. And then 2 by 5, then that's 10. We carry the 1. And then 2 by 2, that's 4 plus 1, 5. Let's see. So this is 5, 2, 6. Yes. So this is 625. Now, this is certainly a multiple of 5 that is greater than 25, which is going to give us this. Now, folks, a bit of trial and error obviously is going to have to kick in. Let's check. How about, I know 30 goes to 900, so we want 2. Excuse me. If we want 2, what about 40? Let's try 40. It's 1600, so it's not going to be there. Maybe 45. Let's try 45. Of course, guys, trial and error along the way is the way forward. So this is 5. We carry the 2. 5 times 4, that's 20 plus 2. So this is 22. 4 times 5 is 20. Carry the 2. 4 times 4 is 16 plus 2, that's 18. So this is 5, 2, 0, carry the 1, so this is 2025. Oh yeah, this is 45 squared. Okay, so this is cool. So this is a perfect square. So we know that m squared minus n squared is equal to, if we check this, this is 45 squared minus 2 squared. So you see we had to check some things here. Now if we can do this, guys, this is perfect, because if these are to be equal, it means m must be 45 and n must be 2. So therefore m is equal to 45, n is 2. So what are we looking for? M plus n. This is 45 plus 2. No, it's minus n, excuse me. So this is 45 minus 2, which is 43. So the answer is C. Okay. Strange stuff. Strange things happen like that. All right, so I mean, now we did not use our friend. Why? Is it necessary, or perhaps the approach is crazy? Okay, let's just check it in another approach. So the same situation we could look at and say, fine, we can say here m squared minus n squared is 2021, right? But if we look at this 47 into m plus n to the minus 1 is equal to 1, this implies that 47 over, writing this as a positive exponent, is going to be like that. So this is over 1. If we cross multiply, we will see that m plus n is going to be equal to 47. Right. Cool. Now, if we play a bit of a long game now, let's shrink this one away. Let's just take it all. Okay, so if we look at this expression, now we know that that was a difference of 2 squares. So we have m squared minus n squared equals 2021. Now this implies that m minus n into m plus n is equal to 2021. Now m plus n is replaced, so m minus n into this becomes 47 is equal to 2021. So this means m minus n is 2021 minus 47. Okay, so this sends us, up an incline as well. So let's move this one in. So if we look at our long division, so we've got 47 into 2021. So now we ask ourselves, how many times does 40 go to 202, for example? Because it won't go to 20. So maybe if we say to 200. Now, of course, a bit of trial and error, folks, is going to just keep coming. So let's just say 47 multiplied by, let's say 4. Of course, we're not sure what we're doing. So 4 times 7 is 28. Telemarketers must go away. So this is 28. 4 times 4, 16 plus 2, 18. So this is 188. So probably 5 times. Okay, let's check it. So let's say 5. 5 times 7, that's 35. Nah, it's not going to work, right? 35. And then, yeah, this one is already out. It's going to give us something else. 5 times that is 35, okay? 5 times 4, 20 plus 3, 23. So this is 4 times, okay? Basically. Konje besithole bani phana senilibele. Best 10 times 4, 188. So we will say 4 times. 4 times that is going to be 188. Right, so we can see we have an issue now. We have to borrow 10 and then we borrow. We've got 12. So 12, this is 4. 9 minus 8, 1. So that's 0. We drop the 1. And then 47 to 141, probably 3 times. Ne? Let's see. Yeah, some questions, guys, certain approaches are going to leave you hanging. As you can see, you end up doing too many things. So let's have a look. 47, let's say times 3. So this gives us 21. We carry the 2. This is 12 plus that is 14. Indeed, it's 3 times. So that becomes 141. Then we get 0, 0. So this is 43 times indeed. Wow. So we can come back, make our conclusion and say, therefore, is going to be 43, our quotient. Nice. So, of course, this approach is causing a few problems because more stuff to try out. But guys, knowing this, you can almost guess which number to try. Get around things, sort them out, unless you are lucky to be able to see it the first time. But again, you see, the trial and error still had to kick in. So either way, the work is done here. Okay, so this is perhaps a second approach to the same problem. As you can see, folks, you need to get comfortable with certain skills so that this doesn't become painful. Okay, let's look through question 24. So question 24 says, A plus B are the first 2 terms of a geometric series. Right, now the sum of the series is this one. But remember, we are not told how many terms are here. So once we talk about a geometric sum, remember, if this is divergent, it can be as many terms as God wishes, right? And it never stops. But if we have a specific sum, this means this cannot be a divergent series, right? Because if nobody tells us how many terms are here, and all of this is in this manner. So this is somewhat a sum to infinity, because a sum to infinity, as we can say safely, there are infinite terms here. Nobody specified how many they are, and everything is generic here. So likely this is a sum to infinity. And if there's a sum to infinity, then this is a convergent geometric series. Okay, so there's a lot you can read from the statements. Sometimes they look vague, but they carry a whole lot of information to someone who pays attention to detail. Okay, so the second thing, we are told that b minus a is 12. So now we need to find a plus b. Okay, so we're saying here we're getting the vibes of a sum to infinity, right? And then the sum to infinity is minus 27 over 4 is equal to a, is the first term, right? All divided by 1 minus r is going to be b divided by a, isn't it? Yes. So this implies that minus 27 over 4 is going to be equal to a over, when we sort this out, it's going to be a minus b all over a. Okay. So this further implies that we've got minus 27 over 4 is equal to, this flips, we get a squared over a minus b. Now we want to create something like that. This is going to be a squared divided by, if factor out a negative, we get b minus a. Okay. Now this further goes to tell us that we've got 27 divided by 4 equals a squared all over minus 12, because b minus a is 12. Okay, so we can cross multiply here. Now this implies that a squared is going to be equal to, first of all, negative times negative is going to be positive 12 into 27 over 4. Right, so what happens? This goes once, goes 3 times. Right. And then let's sort it out. So 3 times 27. Okay, I'm not going to stress myself. 27 times 3. Sometimes be humble. 3 times 7 is 21. Carry the 2. 3 times 2, 6. Plus 2, that's 8. So that's 81. I don't know why I didn't think about it, but well, it just is what it is, right? So this is basically 3 to the 4. I don't know why I didn't see it coming. But hey, be humble. So we know that this is a perfect square. Take a square root. Nice and easy. So this tells us that our a is plus or minus 9. Okay. Right, so what are we looking for? A plus b. Now let's think about it. In this case, we can see that b should be, now this is going to be 12 plus or minus a. Let's say a is positive, right? So if a is positive, this is b minus 9. When we bring it across, b can be 12 plus 9 is 15, right? Don't lie. You cannot say that. It's 21, right? Yes, 12 plus 9, 21. Yebo. Or b is equal to, let's say b was a negative, so this would be a plus 9. Bring it across, 12 minus 9 gives us a 3. Right. Now the question says, what is the value of a plus b? Okay, so if we look here nicely, already a plus b cannot be 21. It can't be. right? Because b is already 21. Right. So let's just check the possibilities. We can say then a plus b is, we can have here minus 9 plus, when we had minus 9, we need to choose the pairs now. This gave us this, whereas this gave us that. Okay, so if we choose minus 9 plus 3, so this is minus 6. Do we see something like that? There it is. Or a plus b is itloba mang 21 plus 3, right? No man, a is 9 plus 21. This becomes 30. So we don't see 30 here, so definitely the answer is D. So therefore answer is D. Okay, this got a bit messy at the end. As long as we got it, folks, this is what matters. So you can see some problems are not straightforward in terms of what solutions need to be brought about. So you get those uncertainties. So you've got to check all possibilities. Don't just be a person who looks at one aspect. You will die a slow death. Even when you have a solution, you might actually find yourself questioning yourself. Because we love to reject solutions too soon. So this means this is what is correct. So what was correct was this guy and that guy. All right, easy, no problems. So please, folks, always try to read statements that are given with care. Stay away from being superficial in thought and being erratic in logic. Okay, this one tells us M and N are the respective maximum and minimum values of this expression. So we've got cos theta minus root 3. The moment I see a root 3, I know special angles are in the mix. Okay, now we need to find the maximum, versus minus the minimum, which is that. Okay, that's not a problem. But now this is not good like this. We can't work with this. So what are we supposed to do? Remember, in maths we can multiply by 1, but a magical one. Right, since we see that we've got special angles, we've got cos theta minus root 3 sine theta. We can multiply this by a 2 over 2, right? The reason is to try and introduce a 2 at the denominator so that we can have our special angles. The next thing, foil it out. So we end up with 2 over 2 cos theta minus 2 root 3 over 2 sine theta. Okay, so that's cool. Now, this is what we were doing there. We're multiplying by that special star. Now we can see that we can actually factor out a 2 here. It's a common factor. So 2 out leaves us 1 over 2 cos theta minus root 3 over 2 sine theta. Gymnastics, folks. Now we have something that we know and can identify. This is either a sine compound angle identity or a cos compound angle identity. All right, so it depends on how we want to do this. We can change this to cos and sine if we wish, or we can change it to cos. So either direction would simply work. Now I'm just going to choose the cosine one. So this is the same as cos 60 degrees times cos theta. In fact, let's let cos theta lead the way. Remember, multiplication is commutative, so there's no stories here. Minus this one is the same as sine theta. Then root 3 over 2 is the same as sine 60 degrees. So I chose the cosine compound angle identity to deal with here. So this is 2 into. Now, when we contract this, technically this is just 2 times cos of the first angle, theta. Now, when it was a negative, it changes to plus 60 degrees. All right, so this is cool. So where will the maximum be? We know that the maximum is going to be at 2. So we know that therefore M, the maximum is going to be 2. And N, the minimum is going to be minus 2. Okay, so we can say then M minus N implies that we've got 2 minus into minus 2, which is 4. Do we see that? Yebo. The answer is option A. Nice and easy. So you see, guys, you know the things, so therefore our answer is going to be A. Wena tlakwana man. Ke re bue nyana wa bona. So do you see, guys, strategy. And I can tell you, folks, this contraction, you can check it. It is checkable. Of course, with the calculator. It's checkable with the calculator, but I mean, you don't have the luxury of this. In fact, let's just abandon this thought. But all I wanted to say is, if you are not so sure if this is correct, put any value for theta and do this on the calculator, and then give a value for theta again there and do it. You will see the answer is still the same. So maths is true, Buffett. Whether you like it or not, it just remains a true. Let's look at question 26. Question 26 says a cylindrical metal pipe, water pipe, is 1 kilometer long. The outside diameter of the pipe is what the outside diameter is 1,04 meters, and the pipe itself is how many millimeters thick? Is 2 centimeter thick. Is thicky. Okay. Now, picture it. Without a picture, you'll be dead here. What is the approximate volume of the metal making up the pipe? All right, so we know that. Okay, all right. Okay. If we can just picture this pipe, let's just do some 3D dons here. Say, okay, there's our pipe. I'm gonna just try stuff like this. Usamos tecnología. Technologia does technology things. Technology things. So we will always win with technology. Technology is doing technology things. Kenaka. Obatla ungetsa. Wona he jwale. Ha re no utlwana jwale. Wena ha o batla o dula mo go beileng o tlo ntena. O batla ho nketsa. Okay. So this is the stuff, folks, that we have here. So again, we want to create this 3D structure. Is it structure? The structure. It's like heat. Okay? Spare that it's just trying to do its own things. And now we are told this thing is also thick. Some thickness, okay? Soyenza bafethu. So basixelela lento. Okay, so this is like a pipe like swa. Now with this pipe, what do we know? The length is 1 kilometer. The length is 1 kilometer. Right, so this is this dimension here. So this dimension is 1 kilometer. Now when we talk about the outside diameter, it means from top to bottom, through the contour, stuff like this. This diameter, we are told, is 1,04 meters. Then this dimension here, the thickness, is 2 centimeters thick. Okay, so this is essentially what we are told. Now our job is to find out what is the volume of the material that made up this metal. So obviously if we cut this metal straight through, let's say we just cut it here and open it up, we reiseha hona mona. We section it here, cut it open. Obviously we're gonna cut it through this part as well. Ne? So we cut it open and then see njalo. So when we open it up, we end up with a sheet like this. So we end up with a sheet like this after we have done the opening. Now, once we have done this, well, we don't know who's longer than who at this stage. I would still believe the length. Let's just assume the length is still 1 kilometer. You know, looks possible to have it like that. Maybe not. It doesn't really matter, does it? Yeah. And then we know that what was going to be the circumference becomes the width. Right, now the width is going to be the problem here. We need to deal with it. The width here is the circumference here. Okay, so we need to deal with that. And the lovely thing is that the height of this thing is that 2 centimeters. So we know that From top to bottom, this is 2 centimeters. Now we need to deal with the width. Okay, how do we deal with the width? We know that circumference is going to be 2 pi r, or we can say pi diameter. Sometimes it's pi d. Let's just take that, perhaps pi d. Nice. Now, we were told what the diameter is. So the circumference is going to be pi times 1,04 meters. But I think since everything is in kilometers, why not change to either meters? Okay, the answer is in meters, so this is cool. We leave it like this. So this is our circumference. So this means our width here becomes 1,04 pi meters. Okay, right. So that's cool. That's cool. So unsure of myself. Okay, we need to convert the kilometers to meters here. So how do we do that? From kilometers, we know if we have a big number, we want to take it down, we're going to multiply. So this is nothing but 8,000 meters. Okay, cool. Here we divide by 100. So this is going to be 1/50. Now 1/50, 50 goes 0 times, and then 0 times, and then 2 times. So 0,02, ne? Yeah, that's 2/100. Cool. So this is now meters. So that's cool. So now we are ready. We are ready. We know that volume is going to be length times breadth times perpendicular height. The length is 8,000 meters multiplied by the breadth, which is 1,04 pi, multiplied by 0,02. Now let's continue. V is going to be 1,000. I don't know why I put the meters. There's no need. Then multiplied by this, converted to decimals, it's going to be 1/04/100 pi Okay, multiplied by, this is going to be, maybe I should have left it as 2/50. Ne? Why not? Why not? Why not? Now we can do the things. The volume here. But I don't see pi here. That's just my only problem. I don't see pi. Why? Maybe this 22, maybe this thing is going to have something to do with 22/7. Ne? Yeah, so this is 8,000. When I multiplied by 1/04/100 pi, we take it to be 22/7. But sometimes you can check on the information sheet if anything like it is given here. If not, you need to know it from grade 9. It's not given. So from grade 9, we know that pi is 22/7, right? Although it's a non-terminating decimal, but when we make it, it's like this, so 2/50. Excuse me, did I say 2/50? No, man. 1/50, man. Or it's 2/100. But perhaps, perhaps it's best if I leave it as 2/100. Ne? There was no need to simplify this further, or 1/50. Okay, let's leave it as 1/50. It's not a big deal. Right. So, re na le bothata. Bothata ba rona ke hore 22. This goes 11 times 2 there. And 2 here. 2 here goes 50 times. Okay, it's just going to be some nasty simplification times. Right, so this is 104/50 times 11/7 times 1/50. See, I'm already writing something wrong here. 104. Okay, I'm worried about my spice. My spice is getting finished. So we know that 50 goes once to 1,000. We know that this and that go away. So we know that 5 goes once to 100 goes 20 times. All right? Am I right? Yes, I am. Yes, I am. Then the next thing, we know that 50 here. Okay, we can say here this and that go away. Now we've got the things. But I still have numbers I don't like. Is there any relationship between 7 and 104? Don't stress. If you don't remember, don't stress. Long division. 7 to 10 goes once. 1 times 7, 7. And then we can borrow. Then we salo 0. 10 minus 7 is 3. Drop the 4. I feel like it. Yeah, it's gonna work. 7 to 34, so 28. Is the denominator, man. Yikes. Re tlwaela hampe jwale. Yeah, I feel like I'm botching this one. What in God, man? Why is this not doing it? Once, yeah, 3. Drop it. Okay. Now something is not doing the things I want, but it's okay. I was hoping something goes. But ke ngoku into eseleyo apha is a problem. Is a problem. Okay, let's just deal with this problem. We multiply all the numerators. So this is 22 times 104. Masiyenze. So 22. Yeah, man. Let's just say 104 we're gonna see what happens. This is 4 times 2, that's 8. 2 times 0, 0. 2 times 1, 2. Then 2 times 4, 8. 2 times 0, 0. 2 times 1, 2. So this is 8. 8, 2, 2. So 2,288. All right, let's write it out. So this is 2,288 divided by 5 times 3. No, times 7. This is 35. This is not gonna work, is it? Bona. Kandido ningo. Kategoli guche bad. Kategoli guche. I out to see and fun. So 35. I'm feeling like we're gonna fail here. I don't trust it. With 35, with 288, problem with 35, it can't give us 8. Angiqondi kahle. Akiqondi man. Something is not right here. All right, 35 to 228. Yo, guys. The question pela kwa decimal payan. Oh, wait. Superb. Approximate. Izoba ne decimal. Yare. Kabatla ke shwa ke bolawa ke ntho e bonolo swa. Okay. Now let's do some trial and error. 35 to 200. City times City 6 bonage. This is 36. It's already not doing the things. All right. 6 times. Oh, we carry the 3. It's not 36, 40. 6 times 5 is 30. Carry the 3. 6 times 3 is 18. Plus 3. 18 plus 3 is 21, right? This is 210. So yeah, it goes 6 times. Sis, I guess I'm 18 now, and then this is gonna give us 210. We subtract. This is 8. This is 1. This is 0. We drop the 8. 35 to 188. 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 Yabana bata sende inugisa le. Say inugale. Inuga to age. Inugu age. Let's see. 35 times 5. Kubani. 5 times 5 is 25. Carry the 2. 5 times 3, 15 plus 2, 17. So that's 175. Iyagai 5. Iyagai 5. Yeah, well, 5 times. 5 times that is 175. This is 3. This is 5. This is 0. So do you see there's a remainder? 53. 65 times remainder 53. Okay. So approximately, guys, 65. So 30 whole number, man. See this approximately, it's not far from 65. So that is 64 nabafethu. The answer is 64, comma some change. Obviously, let's just say approximately 64. Of course, there's a way of doing this to avoid this nonsense I'm doing here. You just go to the nearest. I mean, if you look at this, you can just go to the nearest ndondons. Then it should give us something close to this, you know. Once we get here, we know these ones are not going to divide nicely. So we check, this is 2,288. So this is more like 2,300 if we want, or we can say 2,290, for example. Yeah, something like it. So you can easily say 2,290 over 35, for example. Maybe it would do the trick, because why not? Why not? Yeah, bafethu le question ifuna unihlangisa kodwa ke as long as kuno 6 no 5 nanthatha le. Nawe kuzazibonela ukuthi ukhethe iphi. Indlela zimbini. Wena ukhethe yakho, right? We stayed through to the maths, guys, but you can already see this one is good, but it's not a bad estimation because your price is clear. So yeah, because of our friend. All right, yan pambanisa. But I think say shy. If we see an answer close to it, simkanayo bafethu sishiye khona apho xa sigqiba. Yeah. Kamnandi, this thing has an answer down below, so you will be able to check it. Maybe we'll check it later. We don't want to copy masiyayiqonda lonto. It's easy to force Stella zinto masowazi. We need to struggle first. 27. I'm pretending I'm moving. Question 27 says in the figure P, Q, R, and S lie on the circle. So these are concyclic points. If these are concyclic points, this is a cyclic quadrilateral. You see that thing I told you earlier. QPS is 90 degrees. QPS, this one. So this already tells you and I this is a diameter. Although it's just being stated indirectly. Always, guys, think about it. So it means the line connecting Q to S, because that's the arc that subtends QPS. So that arc is the diameter arc, technically. Now we need PR. Okay. We want U. Who are you then? We shall find it. We shall find out. Okay, so let's think about it. If we want... So we know that, folks, if that is 90, opposite angles of a cyclic quad are supplementary. So this is also 90. Okay. So PR... PR. Okay. Right. I'm thinking about it, but it's not trying to come to me. Okay. But here I see sine, cos. Yo. Nansi question bo. Yewena. Ufuna undenzani? Oh. Nansi into endingayiqondanga. Sometimes when you don't get a clue, guys, look here. What is going on? We want to find out a plan. There's a PQ. This one. There's a PQ. Hey, it's happening, this PQ. If we vela 3, chances are one of them, yabo, opposed to what only shows up once. Away, that might be the way, but the way I'm looking at it, if PQ shows up 3 times, we need to explore something that uses PQ. Now, if we look at PQ, it's a common side to these triangles here. This one and that one. Okay. All right, okay. If this angle is x, this one is also going to be x, right? Angles in the same segment, subtended by chord PQ. Just trying to see where is this coming from. But the issue now, this one will bring up PS. If we use similarity, okay, it's on GG Lele. Okay, let's just start nicely, guys. There's no need to panic. If this is 90, so this is 90 degrees minus y, that angle. So that's 90 degrees minus y. Ne? I don't know why I'm panicking. You see, not following steps is bad because you start rushing with constructions. But if you look here, if this is 90 degrees, this is y, so this is going to be 90 degrees minus y. So can you see this triangle already will give us PR easily, because QP is part of this business here, and we've got x over here, so we can work out what this angle is from sum of 3 angles of a triangle. So if we do that, we're going to have 180 degrees minus 90 plus y minus x, so 180 minus 90 is going to be 90 degrees plus y minus x, so to speak. So this angle is going to be 90 degrees plus y minus x. We can just choose to group this nicely like this. So this is the angle. Okay, cool. So now with this triangle, we can use the sine rule. Nice and easy. So we know that in a triangle QPR, what do we see? We're interested in PR, so we know that PR over sine of the angle opposite is going to be 90 degrees plus y minus x. All right, so this is going to be equal to, we can use QP or PQ as they put it here, over the sine of the angle opposite that, which is sine of x. Okay, so let's see. We are looking for PR, so we cross multiply this. PR is going to be PQ times the sine of 90 degrees minus y minus x, all divided by sine x. So this implies that PR is PQ times this changes to cos of y minus x all over 2. Technically. So our answer is option A. Okay, so you see, just basics. Sometimes you go too far and you end up struggling. So just basics, guys. Calculate all possible angles, and from there you just find a way to deal with it. So we used the sine rule here because the cosine rule introduces squares. It's going to cause us problems. All right, so that's sorted. As you can see, sometimes it's what you know, but you're not thinking about it. So don't let diagrams cause you problems. Basics. With 3D structures, calculate all possible angles first, and then start to look how you're going to move around. Even the options will provide a clue, so don't ignore them. Okay, question 28 says, in the figure, AC is what? Square root 19 units, and the magnitude of B is halved whilst retaining the lengths of sides AB and BC. Okay, the magnitude of B is halved while retaining the lengths of AB, this one, and BC. Okay, so this means this one moves somewhere here, so to speak. Well, let's try to imagine what a half would look like here. Maybe stuff like this. Looks like it. So we end up with this triangle. So obviously this side now is going to be questioned, isn't it? Okay, now it says, what is the area of A prime BC? So obviously this would be the A prime, where A prime is the new position of A. So that should be that one. Okay. So we're basically focusing on this triangle. Okay, so let's have a look and see. What are we gonna do? What are we gonna do? What are we gonna do? Yes. I think this one, area rule, is gonna be our friend. Our area rule. First, we need to find the angle B. I think the angle B is the first thing we need to get, so that when we have it, we can then calculate the area. You know. Loka, guys. This kind of thing is man. I'm thinking too much, man, and I'm not supposed to. These are not big questions, you see. I don't know why I'm getting distracted. But I think we need B. Because if we can get B, we will be able to tell what is this. But the problem is we are not able to use a calculator, so this is not going to be very nice. Okay, I think my diagram is somewhat not true. Let's be careful of it. What we need is this length, and then we move it around. Okay, so we can already see that this triangle changes completely. It changes to this. Right, so this becomes the A1. Right, so that is what we get. And here we still have our original square root 19. Now I'm thinking the best way to find the size of p is to use the cosine rule first. But I'm a bit skeptical. Do I need to? I don't think I have a choice, huh? I don't think I have a choice at all. But if I do that, I'm gonna run into some serious problems. I can't use the calculator. A by fit. Hi, wena man. Ubatla ring jwale. So this is 3. Okay. Yeah, I think I don't need this. You know? I think I don't need this, do I? Okay, let's just start and see. We know that cos b in general is going to be 3 squared, which is 9, plus 5 squared, which is 25, minus 2 into 3 into 9. Wait. This is going to be minus root 19 squared. That's the one, divided by okay, maybe I'm too quick. Let's start properly. We know that in triangle ABC, I'm feeling a bit uneasy right now. We know that AC squared is going to be equal to AB squared plus BC squared minus 2AB times BC cos of B. Now this is root 19 squared is equal to 3 squared plus 5 squared into 3 into 5 cos of B. So this is 19 equals 9 plus 25. This is 15 by 2. That's 30 cos B. Right, so we've got this is 19 equals 25 here. This gives us 34, right? Yeah, boy, yes. 34 minus 30 cos B. Now we move this, it's going to be 30 cos B is equal to 34 minus 19. And then cos B is going to be 34 minus 19 divided by 30. Nice. So This is 5. Okay, 14 is minus 9 is 5. 5, and then that's gonna be 15. Yeah. So this is minus 15. So cos B is gonna be minus 15 over 30. Right, of course you can do the things on the side, so this means cos B is going to be minus a half. Okay, yeah, I don't know why I hesitated. I was not too sure about this, but remember that's an acute angle. So we're going to ignore this sign. So we know that B is going to be the arc cos of 0,5. Leave that one, leave that one, leave that one. Therefore, B is 60 degrees. Of course, this would have been minus 60 plus what is minus 60 is plus minus cos cos. Oh yeah, this would have been 120, né? But that is not 120, it's an acute angle. Now I'm thinking about it. Is it possible that that angle is 120-ish, guys? Because arc cos of a minus half is 120. It's a special thing. Because sometimes what the sketch looks like, it has to be taken like that. Now I'm thinking, okay, let's just solve and see if we're going to find these solutions. If we do, we pick one. Now, after this, we know that this angle has been halved. So we know now that, well, area of A, B, C is going to be half of 3 times 5 times sine of 30 degrees, half of 60. So this is going to be equal to 1 over 2 into 15 into 1 over 2. So this is going to be 15 over 4 units squared. Hayi nanke bafana. If iphumile ngihamba nayo. I'm not stressing, ne? Otherwise, ukubilayela forever is not working, you know, it's not working. So don't bilayela for life, ne? Bilayela just for a moment and then move on. So I'm gonna take that A. I intend confidence lentally. But I think our approach is good. I mean, it's an acute angle. Unless someone tells us that B is an obtuse angle, then we can entertain. If we get the answer, take it and go. Take it and go. But again, you can check. If you say this angle is 120, for example, you can check it that way. Then use 120. Half of 120 would be 60. Sine of 60 is root 3 over 2. Right? So we do have root 3 over 2, which would give us 4 in the denominator and root 3. But where did the 7 come from? Because 3 times 5 is 15. So that should be 15 root 3 over 2, not a 7. So none of these solutions cater for 120 there. So it's not going to work. So I am a bit confident of that one. Question 29 says, if y minus 1 over y is equal to 4. What is the value of this thing? Hey, I wanna get this question. So let's say y minus 1 over y is equal to 4. Right, okay. Now what I see here, there's a square, and the one thing about this one is that when we divide each by the numerator, we're gonna get stuff like this. So that is gonna be squared, so we don't have a square here. So we might as well do the gymnastics here that we know how. We can square the one side and see what happens. So this is going to be y squared, y times that is going to be 1, so it becomes minus 2 plus 1 over y squared is equal to 16. Right, so we can move the number to the other side. You can say therefore y squared plus 1 over y squared is equal to 18. Okay, that's fine. Then y squared plus 1 over y all squared minus 10 is going to be equal to, if we sort this out, we're going to get y plus 1 over y all squared minus 10. Now when we square this, we get y squared plus 2 plus 1 over y squared minus 10. Now we saw that this and that is 18. So this is now 18 plus 2 minus 10. So this is 20 minus 10, which is 10. Do we have that? B. All right. So therefore our answer is B. Okay, not a bad question. Let's move it. Move it. Question 30 says, cos x is equal to 4 over 5 and x plus y is equal to 90 for acute x and y. Okay. Right, so sine of 90 degrees plus y is equal to, this one is too easy, né? This one is too easy. This one is too easy. This one is very easy. So first of all, we know that x plus y is 90 degrees. This means y is going to be 90 degrees minus x. Also, we know that sine of 90 degrees plus y is going to be the same as cos of y. Now cos of y is the same as cos of 90 degrees minus x. I got 10 this is jiggy. One jiggy samos. So this becomes sine x. Okay, let's just do the triangle. I didn't want to do it, but I find myself doing it. But why didn't I? Let's see, man. Why didn't we just do this the right way? We should have just Yeah. But I think we can't avoid it. Being told this is an acute angle, so this is x, origin, so cos is adjacent over hypotenuse. So if that's the case, the opposite is going to be 3 from Pythagoras, right? We know that y is going to be the square root of 5 squared minus 4 squared. Y is going to be, this is 25 minus 16, that's 9. So that's 3. Okay, so now this implies that sine of x is 3 over 5. Right, so the answer is B. It's tossing and turning us. Ne. Okay. Let's look at this one. Could we squeeze it in here? Question 31. This one says 3 to the 2x is equal to 5. And 125 to the y over 2 is equal to 243, okay? Now we need to find 3xy. Again, it's one of those indirect, so let's start with this one. Probably I should have put this one here. And say this implies 125 is 5 cubed to the y over 2 is equal to 243. So when we deal with this, this is 5 to the 3y over 2, which is equal to 243. Now what do we know? 5 is 3 to the 2x all to the 3y over 2. This is equal to 243. Now the 2 and the 2 grace us with their absence or their invisibility, so we end up with 3 to the 3xy is equal to 243. Now can we express 243 by 3? So let's see what is happening here. Now 3 to 24, right? 3 to 24 goes 8 times, excuse me. 8 times 3, that's 24. We drop the 3 to 3 once, 1 times 3, 0. So this is 81. So this is the same as saying 3 to the 3xy is equal to 3 times 81. 3 to the 3xy is equal to 3 times 81 is 3 to the 4. So this means 3 to the 3xy is going to be equal to 3 to the 5. Right? Exponential rules. Then this also implies that 3xy is going to be equal to 5. Nice. So therefore, our answer is B. Actually, I'm feeling sleepy. Excuse me. I just want to sleep. I want to sleep. Damn it. Something is on the Ngidinga ukudlazamba intwana ekhona apha ezondivusa. Besiqale kahle apha, ndine-energy ngoku ayisekho le energy. Where did the energy go? I think writing for a long time has a very bad effect to me. My writing just dies. All right. Question 32 says the product of two positive numbers is m. The difference of their reciprocals is n, where n is greater than 0. Okay, positive. What is the sum of the squares of the two numbers? Yeah. Nice thing is word problems. So we're going to say let the numbers, let the numbers be x and y, such that we are told the product is m. That's the first thing. And the difference of their reciprocals, whichever comes first, the reciprocal is 1 over x minus 1 over y. We are told this is n. Okay. And we are told that this is positive. Okay, not a problem. So the question is, what is the sum of the squares of the two numbers? All right, so then let's see. Okay, maybe let's finish up this one. I don't feel like it's done. Here we do the common denominator here. So it's going to be the LCM. X times y is going to be xy. Then we cross multiply, we get y minus x. This is equal to n. And therefore, we can say y minus x over xy is m is equal to n. Okay, maybe not yet. We can cross multiply this. This is over 1. Therefore, y minus x is equal to mn. Okay, let's just do that. Okay, cool. We can say then x squared plus y squared is equal to. Now remember, there's identities here. Sum of squares, difference of squares. Now there's two possibilities. We know that x squared plus y squared is going to be x plus y all squared minus 2xy. Or we've got x squared plus y squared is equal to x minus y all squared plus 2xy. So there's these two possibilities. Furthest thing. Of course, guys, if you forget these, you can create them. Now, which one is going to work in our favor? So we've got this guy, a difference of these. In fact, we can even attempt to create that. So we can say, therefore, if we pull out a negative, it's going to be x minus y is equal to minus mn. Right, this is when we pull out a negative and divide by it throughout. So that would be nice. So it's already giving us the vibes that we're going to have x minus y all squared plus 2xy. So let's see, what is that? We saw that this is minus mn all squared plus 2xy is m. So this becomes, this negative goes, it's going to be m squared n squared plus 2m. So the answer is A. Okay, so that's it. Please guys, learn these things. I have shown you how to work around these identities, and you are taught these in grade 10. Sum of tubes, difference of cubes, sum of squares, difference of squares. As in the identities this time. Okay, not necessarily the factorizations, but this is another way of factorizing them if you think about it. Okay, so you just have to know which one to select to solve the problem. All right. 33. So question 33 says, in the figure, guys, I just I came out of theater last night and all of a sudden I was coughing. I don't know why, but I wore something that was strange. It smelled. You see the clothes smelled like konumntu otya amagwinya phaa wawashiya phezu kwayo, ndibona ingani namafutha amagwinya. Oh, ngoyinto endiyikhohlelayo andiyazi. Hi guys, don't go. Okay, this is in the same horizontal plane, right? A, B, C, and D. So all of these are on the ground. So this is a 2D structure, not 3D. ABC is 90 degrees. ABC is 90 degrees, and CD is what we want. Okay. Easy stuff. Ne? Yeah. So this is telling you and I that we need to work in this triangle eventually. But the nice thing is that if that is theta, this is 90. So this angle is going to be 90 degrees minus theta. So we always work towards the common side, which is this. We need that side from the other triangle. Okay, let's start. We're going to say in triangle ABD, we know that we want BD. So BD over the sine of the angle opposite that. We just cut to the chase at this point, guys. It's going to be root 3, which is the side AD, over sine theta. Nice and simple. So this is the sine rule. Now we're looking for BD, so we can say this implies that BD is going to be root 3 sine of 120. This is as good as sine of 60 degrees, right? So when we reduce that, it goes to 60, sine 60 degrees using reduction formulae over sine theta. Right, so we know that this implies that BD is root 3 times sine 60 is root 3 over 2, all divided by sine theta. So therefore BD is going to be 3 over 2 sine theta. So please guys know how to simplify this without sweating. Nice. Now what do we need? We have now BD. We can say then in triangle BCD, what do we know? We know that CD over CD over sine of 90 degrees minus theta. That would be the angle. Is going to be equal to BD, which in this case is 3 over 2 sine theta. Then all of this is divided by the sine of the angle opposite that, which is 120 degrees. Alright, so this implies that CD over, this changes to cos theta, is equal to, now let's think about this. This is going to be 3 over 2 sine theta multiplied by, okay, let's not rush perhaps, sine of 120 is again root 3 over 2. So this is CD divided by cos theta is equal to 3 over 2 sine theta multiplied by 2 over root 3. So this and that goes CD over cos theta is basically 3 over root 3 sine theta. Cross multiply this. So this implies that CD is going to be 3 cos theta over root 3 sine theta. Now cos over sine is tan theta. So this is 3 something is not right. Oh yeah. Cos over sine is a different story, ne? Cos over sine is 1 over 10. So this is 1 over 10 theta. Ne? So this is 3 over root 3. And then into yami ati hayi wena man, kutheni angathi ayikho le answer nje. Anyway, let's see. So this is multiplied by 1 over 10 theta. Kwentekane nyalo. What is cooking? Oh yeah, they rationalized. Lord of Lords. So if we want to rationalize there, we're going to multiply by root 3 over 3. Oh, therefore CD is going to be, this is going to be 3 root 3 over 3. The 3 goes away, so we get root 3 over 10. Ubatle umpolaya wena man. Ubatla kifufulele jwale. So the first answer is correct. That was the secret. So always check, folks. Therefore, our answer for 33 is option A. Now, we're cruising nicely, are we not? Yes, I think this has injected some energy. Let's keep working. Question 34. In the figure, triangle ABC lies in the Cartesian plane. Alright, A is at the origin, B is at 2 and 3, and then C is at 6 and 1. Okay. Now, what is the area of triangle ABC? Okay, cool. Now, if we look at this triangle ABC, it's not the nicest. No? It's not the nicest, but now I am thinking, what I can do, what if I produce this? Okay, and then I produce this. Right, if I do that, I will work out the equation of this line. Right, what I'm interested in is C, the y-intercept, which would be the point here. Now, if I do that, I know that this becomes the base of the big triangle, which is going to be triangle, whatever this is. In fact, let's call this y-intercept D, A, B, C, D. Let's call that point D. So I would have AD as the base of the big triangle. Now, this is a common base with this triangle. So I don't know, folks, but if this was n minus m, it would make... If we were subtracting these two, I'd say this is the horizontal distance, so it's always an absolute value. So, yeah, folks, I don't know why this had to happen. We will keep it in mind, but I think we've got the answer. At least we got something similar, so I'm going to choose D. Wrong or right? Of course, folks, like I said, this thing has answers to these questions. But as you can see, sometimes you're not sure if you're choosing the correct answer. Unless I mishandled signs along our calculations, it's possible. But I don't see that. I don't see that. So I don't know what happened. Egviet. I don't know. Either way, we move on. So question 37. So we're moving closer to the end. Question 37 says f of x is minus x squared plus bx plus c. AC is equal to a quarter of b squared. And then b over 2a is greater than 0. Okay. So what does this mean? Well, we want to know. What we want to know is, first of all, we know our graph is a grumpy face parabola. So it can be any of these three. And it's certainly not this one. So A is out. Second, we okay, now I'm thinking, you see this expression, if we work it out, we cross multiply the 4, we know that 4ac is equal to b squared. Now when 4ac is equal to b squared, this implies that b squared minus 4ac, when we transpose it, is going to be equal to 0. So this means the discriminant is equal to 0. So when the discriminant is equal to 0, it means we've got equal roots. So this means this cannot be, because this has unequal roots. Interesting stuff. Okay. Right. So we've got equal roots. So now we're dancing with B and C. Now this one has to tell us the rest. So if B over 2A is greater than 0, so what happens? When we take this and move it, this is going to be minus B over 2A. So we are transposing it to this side. If we move it, it's going to be less than 0. You can just think of multiplying by negative here. We know that this expression gives us the axis of symmetry. So when the axis of symmetry is negative, it is this one. You see, this is a negative axis of symmetry. So that's good. And this one is positive axis of symmetry. So the answer is C. What an interesting question there. All right, so here the answer is C. Nice and easy. So please know the graphs, folks. Even when not given anything, values or anything, be in a position to work problems out nicely. So let's have a look at the next question. It looks heavy, but let's try and squeeze it here. All right, so this one says f of x is equal to cos of a half of x minus 30, and g of x is the graph of f shifted 120 degrees to the left. So g of x is going to be, right, if we shift to the left, we expect a plus. We expect a plus. So this is already out. Okay. Right. So now let's deal with this problem. So we know that g of x, okay, maybe let's start by writing f of x. F of x is the cos of half of x minus 30 degrees. Then g of x is f of x plus 120 degrees, because shifted to the right, sorry, to the left is going to be plus 120. So this means this is cos of, where we see x is going to be a half. X is replaced by x plus 120 degrees. Be very careful here. Those transformations can hurt if not done properly. Okay, so this is what we have. So this is cos. Maybe let's just break the big bracket. So this is going to be half of x. Half of 120 is 60 degrees minus 30 degrees. So this is cos of half of x plus 30 degrees. So the answer is B. Pretty easy. Again, just understanding the transformations and how to do them on the generic equation. It makes life a lot easier. Yeah. Let's move on. So question 39. Okay, guys, so question 39 says, A, B, C, D are the first four terms of a quadratic sequence. So let's see, QS, it's A, B, C, D. So we know that there's a sequence of first differences. So B minus A with C minus B with D minus C. And we know that the difference between these is constant, right? So don't wait, guys, for these to come up. So we know that basically C minus B minus A must be equal to the same as this situation here, D minus C minus into C minus B. So that's what we've got. Okay. So we're told the sum of all of these is 36. Okay. Cool. We can do something about it. Now we want 2B minus C plus D. Let's start here. We know that here C minus B minus into B minus A must be equal to D minus C minus into C minus B, because that's the constant second difference. So this is going to be C minus B plus A is equal to D minus C plus B. Now we've got C minus 2B plus A is equal to D minus 2C plus B. Okay, cool. So we move everything that is common. So 2C goes to the other side. We get 3C minus 3B plus A is equal to D. Okay, so we can say safely we isolated D here. So we want 2B minus C plus D. Okay. Now, what I'm thinking, simultaneous equations are going to kick in. We can call this one equation 1. We can say also, we know that A plus B plus C plus D is equal to 36. So this implies that D, or concludes that D is 36 minus A minus B minus C. That's equation 2. Now these are equal, so we know that 1 is equal to 2. So let's see. We've got 3C minus 3B plus A is equal to 3B. No, not 3B, but 36, excuse me. So this is 36 minus A minus C. Ay, Lord of Lords. Nothing is going away here. Anyway, we'll see. If we move this thing to the other side, we get 4C minus 2B plus 2A is equal to 36. Okay, now could we change this and make it look like the other one? 2 can be, 2 is a common factor. So if we divide by 2, we get 2C minus B. Plus A is equal to 36. Okay, so what do I want to get rid of here? I feel like okay, I think here I rushed because there's no A in that equation, but there's D. Okay, ngathi ndiqale ngamawala. Okay, ngathi ufuna ukusipayisisa kancane. These penultimate type of questions are silly, man. Okay, so what is the problem here? Okay, 2B is here. Okay. Ngathi siyijahile. Let's just double check if everything is good. D minus C, then D minus C minus minus. Okay. I think this equation is fine. Now what do I want here? I've got D. Okay, maybe let's take it easy. I think we're going too far. Let's take it easy. Now let's take it as it is. We can say then 2B minus C plus D is equal to. Now let's have a look here. This is going to be equal to 2B minus C plus, instead of D, we're going to put here 3C minus 3B. Plus A. 2B minus C plus 3C minus 3B. Now, we've got minus B. Okay, let's look at this. This is 2C. Okay, there's 2. And then these 2 is going to be minus B plus A. Okay. So this is what we get. Now, we don't need A. So if we solve for A here, A is going to be 36 minus B minus C minus D. Okay. Ngathi le ndifuna undribblisha ke. So this is 2C minus B plus A is 36 minus 6, sorry, minus B. Minus minus C minus D. So yabona hayi man, yabona yung mayingangiqheli mayingandiqheli. This question, Bob. Come on, man. You're messing with us. Awuthi sike siyiyeke ingathi izangihlanyisa le. Awuthi senze ukugqibela. I'm feeling dizzy, guys. I need to sleep. I didn't sleep. I was on duty, so it was quite a night for me. So let me just take the last one and see if I can solve it. F of x is by this 2 sine squared x minus 4 sine x plus 3. So we are told here that k is an element of integers. So we want the maximum. F of x is a maximum for x equal to. Oh, okay, so we're looking for the values of x that give us a maximum. All right, so this is cool. So let's see, what do we notice? What we notice is that this is an identity. This one. It's an identity from cos 2x is equal to 1 minus 2 sine squared x. 2 sine squared x is going to be cos 2x minus 1. Right? So, but inkinga zethu azikakapheli. Our problems are not finished. Come on, man. Come on, man. Come on, Boza. What are you doing? What are you doing? Telling out these questions zokugqibela zifuna ukundihlanyisa nje ngoku. Tipatla hontlwayela. I know we can factorize this thing. Okay, maske sithi emanyana. Ikare remoma tate njwala. Let's take this out. I'm also thinking of completing the square, you know. But if I complete the square, I'm going to run into problems, am I not? I think so. Okay, let's try and factorize and see what happens. So this is going to be minus 2 sine x into sine x. So this must be positive, right? Both of these must be positive. And then to get what I want, you as problems. Icon. Yo, yaban. Kanti wenzakalani. I can move it around and the last two questions are questioning me now. Alright guys, it's an motion, man. I don't want to lose time. I want to teach these guys about regular polygons as well. I don't think factorizing is in any case going to help me here. Yeah, let's not try. Factorization. Yeah, man. f of x is going to be a maximum. I think let's complete the square here. I think that would be the best way. So we take minus 2, then we get sine squared x plus 2 sine x minus 3 over 2. Right, so we've got minus 2 into, we take what is under the square, sine x, the sign between them. Then we have this one, it's going to be just 1. And we square it, then plus 3 over 2 minus 1 squared. Alright, so we've got sine x plus 1 all squared plus this one there is going to be 2, so this gives us a half. And then we redistribute, so this is minus 2 into sine x plus 1 all squared plus minus 1. So this one will give us a maximum value. What would be the maximum value? The maximum value is when this thing is 0, right? Because this is a perfect square. But if it has a negative, it will always be negative. So the biggest would be 0. And then this is going to be 1. So this means this thing must be equal to 0. Alright, so this we can say f will have a maximum such that sine x plus 1 is equal to 0, sine x is equal to minus 1, x is equal to, so this is a general solution thing, it's going to be, x is going to be the arc sine of minus 1 plus k 360, or x is going to be 180 degrees minus the arc sine of minus 1, where k is an element of integers. Okay, so this implies x is, arc sine of minus 1 is minus 90 plus k times 360, or this is going to be x is equal to, this is minus minus, so 180 plus 90 is 270, right? So this is going to be minus minus 90, so this gives us 270 plus k 360, where k is an element of integers. Obviously this is one in the same solution, literally. So we can say therefore our answer here, this one is the 1. So therefore our answer must be D. Right. Because 270 and minus 90 are the same things. So I think this one, hayi uzofa fi imaths ma ungayazi ke mntwana esikolo. Mna ndiyakuxelela ndifuna nokukuqhatha. If imaths awuyazi awusoze uyibone, ne? So born. Great. So you look, you see, you try, as they tell you, completing a square, not examinable. Here it is. This is not lying, you know, it's not lying at all. Excuse me, because no matter what you do, it's gonna work like this. Now I was trying to think, was there another way? Because this looks too long. But I think I would go with the H, guys. Let's go back to that 39. 39 was panel bitil. Something is not adding up here. You know, when something is not adding up and there's too many things to consider, we start afresh. Let's qala phansi. Now we're told these are the first 4 terms of a quadratic, right? So we know that b minus a is going to be the same. Okay, not the same. We're going to have c minus b there, and then we're going to have d minus c. This is a sequence, right? And there's 2. So we're going to have here c minus b minus into b minus a. So what do we get here? C minus b plus a. So we get c minus 2b plus a. So this is c minus 2b plus a. Okay, so that's what we get over there. Okay, so let's see what else do we get over here. So what we're gonna get is gonna be d minus c minus into c minus b. So this is d minus c plus b. So d minus 2c plus b. All right, that's what we get. Right. Okay, all right. So now let's think. What do we know? We know that c minus 2b plus a is the same as d minus 2c plus b. If we move everything to the one side, so we get 3c minus 3b plus a minus d equal to 0, or maybe let's just say plus a equal to d. Right. Now what we want to get rid of is a, because we don't see a in our expression. So we can just say also, we know that a plus b plus c plus d is equal to 36. Therefore, a is going to be 36 minus b minus c minus d. So this implies that 3c minus 3b plus a equal to d is going to be 3c minus 3b. Instead of a, we're going to say plus 36 minus b minus c minus d is equal to 0. And then what do we have now? So this is 3c minus c. This is 2c minus 3b plus, wait, okay, yeah. Minus 3b minus this is going to be minus 4b. Okay. Right, and then we have, okay, maspalis source is this and that, zimkile, this one and this one, zimkile. Now we've got minus d. We can move 36 to the other side, so this is equal to minus 36. Right. Wait. Something did not go very well. Yeah, UD is missing. So remember this A, kusenalo D, so it's not 0 here. So this means when we move that D to this side, we get 2D. And then we move 36 to the other side. Now we've got a common factor here, but now we're going to pull out minus 2 into, now 4b becomes 2b, so that it looks like that. The c becomes minus c there. The d becomes plus a d like this. So if we divide by minus 2, we get 2b minus c plus d is equal to 36 divided by 2 is 18. Nice. Therefore, our answer is option A. Okay. We almost botched it. But yeah, to regroup sometimes it helps because your brain focuses thinking fast. And when it does, you can easily find yourself on a curve out of commission. Okay. Now, folks, that is it for this one. So obviously there is a formula sheet if you need it to remember. So you'll be given these things. And there are the answers, so you can just check which ones we got right, which ones we didn't. And what is important for you guys to make sure you have a look is this stuff, to just understand the complexity of certain questions and exactly the levels. All right, so obviously this should be level 4, right? Problem solving level 3. Knowledge and recall, maybe we can say level 2/1 because it depends on the challenge, but I think level 2 would be best. It's not truly, straight up. So I think this one assesses these 3 levels if one was to think of levels. But again, you will check which questions are which, and you can double check with the answer key here if we didn't botch anything. Otherwise, folks, all is here. If you're interested in this memo, I'm going to put it up in the description down below. So go have a look at it. You can download it as well as this document right here. So this is all thanks to this person. I'm not sure. Alan should be a gentleman, but it could be a lady also. These days names are just given. So yeah, if you have any troubles understanding what I'm doing, probably you can just email the gentleman here or the lady. and ask, hey, how does that problem get solved? Because the full rake that we looked at doing this is not convincing. He was also sweating. So we don't trust him. Okay, guys, so it's either you trust me or you don't. Okusalayo ndikufundisile maths mina. And I love these questions. They're quite enjoyable. Although at times, as you could see during the video, they are quite frustrating. Because they ask you more than you are ready to give, right? Or more than you have ever had to give answers. Anyway, folks, let's talk about regular polygons quickly, because I feel like this is the one thing that I probably have been neglecting. So let's just go back to our midway. So let's talk about regular polygons so that you guys know something about them. Because I don't want you guys to get caught pants down. Let's just quickly talk about these. Then we're going to take some questions based on these. I'll probably do just 2. Then you can look for the rest. The idea, folks, is just to teach you enough to know what to do. And you can handle any other question. You don't have to be shown how every other question works. Now, in a regular polygon, these are the properties here. All sides are equal. And also all angles are equal. So this is very important. And the most important is that these are inscribed inside a circle. Well, they're inscribed inside a circle, or you can say there is a circumscribed circle. There is a circumscribed circle. Always. It's not a matter of sometimes. It's a matter of always. So these are the notes, folks, you need to know. Now let's take an equilateral triangle. This is the most basic regular polygon you can think about. I mustn't kill when do the things I'm sending you to do. So let's imagine this is our equilateral triangle where this side is equal to that side. Obviously, we said there must be a circle passing through the vertices of our lovely things. Okay, guys, it's not perfect exactly, but it's doing the job. So basically, we have this situation. Sometimes you may ask yourself, why the heck are these angles 60 degrees? Because you'd be like, I know in an equilateral triangle, I've got 60 degrees, but how on the Lord's earth did this happen? Let's say we didn't know. Now we want to find out. Now, folks, we know that with any circle, there is a center somewhere. Now this center, if we just make some constructions, we'll see that the sides of these triangles become chords of this circle. They become chords. Right? Right. Now, we know that equal chords from Euclidean geometry will create equal angles at the center. Right? So that's what we know. So if we let one angle be equal to x, what is the story? We will know what is the story. The story is that we get 3x. So we know that x plus x plus x So we know that 3x is equal to 360 degrees. Why? This is a revolution. Or you can say angles around a point. So therefore x is going to be 360 divided by 3. Is it 120? Ek denk so. 120 degrees. If you don't know, do it. Now we're going to do this without a calculator, just so you guys can get used to working these things out. 3 to 3 goes once. 1 times 3 is 3. 0, drop the 6. 3 to 6 twice. This is 6. Drop the thing and 0, so we drop the 0. So 3 to 0, 0 times 3 is 0. Like that, I could remain up higher. So do you see it's 120? Just so you know. So now this is 120. So this is the angle at center. But now if I'm looking at this angle at center, maybe let's make it nice and easy. So we're looking at this angle at center. What would be the angle at circumference? For the same chord or arc. Right, so we're either looking at this arc or we're looking at this chord, depending on how we look at that. So we know that the angle at center is 2 times the angle at circumference. So we can say if this is A, B, C, we know that angle A as a whole is going to be half the angle. Let's say this is center O. So it's going to be half BOC. Right, angle at center is equal to 2 times angle at circle. So this implies that A is going to be half of 120. Therefore, A is 60 degrees. Right, and this is going to be the same for each of these angles because each one of them are 120. Remember, this is 120 and that is 120. So all their angles at circumference are going to be the same because these are equal chords. So that's why all the angles are 60 degrees. So in this case, we can make a conclusion that therefore A is equal to B, which is equal to C, which is equal to 60 degrees. Right. So at this point, we can even just say these are angles subtended by equal chords. Because if a chord subtends 60 degrees at circumference, then all of them should be the same. So this is just to get you guys to knowing how to find your way through, all right? So obviously in this case, there's another property that we need to explore. It's the property of the sum of these angles, right? So what is the sum of angles of this? So we can say the sum of angles here is going to be, well, we can say here 180 degrees, right? Because this is sum of 3 angles of a triangle. Sum of 3 angles of a triangle. So that's easy. So these ones add up to 180. Right. So we are done with this one. So please know this situation. But now we're going to talk about why are we looking at this, because it helps to know it. Now let's look at another regular polygon. I'm just going to look at 3. Then from these 3 we can map out what we can do about them, because this way you will then understand how these things work. The second regular polygon is a square. Right, so this is a square, and we know that there is a circumscribed circle, right? Hayi man. Iyangixhela ke man. Sikantina wena man. Okay guys, izamile. Asinoyinceda ukuthi ize ihlale nca. We tried, so it doesn't really sit nicely. So if we're going to say this is A, this is B, this is C, this is D. So now what is cooking here? Same thing. A circle has a center, guys. It always has. And if we make constructions of those ready, right, all we get is that equal chords will subtend equal angles at circumference. Right? Right. So this is what would be the case. So if we name one of these angles X, right? So what are we going to end up with? We're going to get 4x is equal to 360 degrees. So that's a revolution. So this means x is going to be equal to 360 by 4. It's 90. Right? So we get 90 degrees. But now since these two are the same, right? Adding those up, they make up the angle at center, and the angle at circumference is that one. What is it? So we know that from here we can say D is going to be half of the angle A. Okay, let's call this center O. It's going to be half the angle AOC. Right, again, angle at center equal to 2 times angle at circumference. So this means D is going to be equal to a half of, this is now 90 plus 90, which is 180. So D is 90 degrees. All right, the same will apply each time, whatever you look at for all these other angles. So that would be the case, essentially. Right, and of course, if you just want to use the simplest issue, I mean, this is 90 degrees, so all the angles are 90 degrees. So in this case, we know that D is equal to A is equal to B is equal to C, which is equal to 90 degrees. Okay, here, I don't have a reason, but we can just say angles of a square, because at this point, we don't have to worry about anything. This is a polygon, okay? A regular polygon, all the angles are equal. So if we found one, we have found all of them. So we can just say angles in a regular polygon. Right, some other situations will force you this part. Okay, so that's cool. So we know this about the square, okay? So what about the sum of these angles? We know that the sum of all angles is going to be equal to 4 times 90, which is 360 degrees. Okay, so we know that all quadrilaterals behave like this. As long as it is four-sided, this is going to be the case. And we know that all triangles, as long as it is three-sided, the sum is going to be 180. Now, folks, is there any link to this? Could we perhaps see a link? But maybe let's take one last regular polygon so that we can start to formulate some hypothesis if indeed it works. Now let's have a look at a pentagon. Wrong. Konje pentagon injani. iPhone. Okay guys, we can assume everything is working out nicely. Let's take you to the center. So we said there's a circle passing through the things. Okay, even this one almost became as good as I want, but it kind of did not want to do the job. But it's not too bad. So we've got a pentagon here. So with a pentagon, again, like any other thing, we know that there's going to be a center somewhere. And if again we do the ready, remember this is a regular polygon. All sides are equal and all angles are equal. But now we want to know what is the angle. As you can see, for a square it's 90 degrees. For a triangle, equilateral triangle, it's 60 degrees. So what happens to a pentagon? Still, we know that these sides are equal. And we also know that these angles are also equal because it's a regular polygon. So those angles are equal. So what do we do? So of course we've got our center O. Now obviously guys, we know that at the center these angles are also equal because they are subtended by equal chords. Right? So all those angles at the center are equal because they have equal chords of the circle. So we can call this one A, B, C, D, and E. Right, so what can we do? Same story. If we call this one X, all the others are X. So we know that there's 5 of them now. 5X is going to be equal to 360 degrees. Again, we've got a revolution. Right, so this means X is going to be 36 divided by 5. Is it 60 degrees or is it 20? I'm not sure. Must see 5 to 360. Right, to 5 go 36. Yeah, guys, 6. Yeah, it should be 60 degrees. So this is going to be 36. Yes, 0, 0. So we drop the 0 there. 5 to 0, 0 times 0 and 0. Yeah. So this means X is going to be 60 degrees. Right, so that is the story. Okay, cool. We are fine. But now to find, if we want to zoom in at A is going to have to be looked at in terms of this whole angle. Right? Because the arc must be BE. That subtends A. Right, so if we look at that, we can say then, we know that angle A is going to be equal to half of, how many X do we have? 1, 2, 3. So we're going to have 3 times 60 degrees. A is going to be equal to 3 times this. So this is 3 times 6, that's 18. So this is 180 degrees. Now, what do we say? Are you kidding me? Therefore, A is 90. Ayuwena. Ring. Did I do it right? Yeah, 18. Bring the 0. It's 180. Half of 180 is 90 degrees. Okay. Interessante. Tena ningayithembi kodwa. Hayi guys. Tengathi yangiqhatha ngokulento. Awunifaki ichatho nje wena. Hayi khona. Unkenya 1 2 3 4 1 2 3 4 5. Hayi theni yaba njengesikwengo. Andiyithembanga ke le. Ingathi ngidlisa ushevu nje. Wena ntshella dintho. Watla ho mpolaya ke a o bona. Ihlile ke a o bona. O mpatla ke shwile. Hayi guys, theni ngathi ndiyibhoncile nje. Ndiyibhoncanga nje. Kwenzeke ntoni apha? Ndiyibale kakuhle kodwa le nto. Yintoni le ndiyenze kakubi ngoku? Udlalile ngami bo. Yanibale zomqala. Ndiyibhude apha yonke le nto. Ayikhange ilunge nje. Imosheke phaya. Okay, 5 to 360, right? So 5 to 36 goes to 35 7 times. 7 times this is 35 minus. So 6 minus 5 is 1. This is 0. We drop this 1. 5 to 10 2 times. 2 times 5, that's 10. 0. So this is 72. I wonder then that chaya AP in Tango man. Kileka smoke something. I smoked something. So that is the story. Now everything changes. That's why man, I was skeptical. This 90 can't be here. There's no way. Now 3 times this. Don't sweat again. 72. Just use the tools, man. 3 times 2, 6. 3 times 7, 21. 2, 1, 6. Yes. You get it. So this is on the 100. 200 divided by 2 is 100. So this is going to be 10. We leave the other 0 because that's the 16. 16 divided by 2 is 8. It's 108. If I was asked as tricks, uzava ngathi uyasha ube useyasha balala. Uzaza ngathi uyasha ube usuyasha balala. Awuthanda ungathi 200 divided by 2 100 bese sithi 16 divided by 2 ngu-8. 100 plus 8 is 108. Yayibona mos. Sometimes ezinye number nje vele wenza into zakho. Now inyani yonke lento ithethe inyani impela. Ithethile yayigqimba. Inyani yabona, it's an obtuse angle there. So now ndiyayikholwa. Then singabe sesiyaconclude sithi therefore u-A ulingana no-B, alingane no-C, alingane no-D, alingane no-E, which is 108 degrees. The reason, we can just say angles in a regular polygon. So xa ufumene 1 uzifumene zonke. Yabona siyifumene ngamaqhinga. kamaleba. Hayibo guys, funa ngixaba sekuyophela 3 hours masingaqhelwa kabi. Now let's see what is the sum of these angles. Sum of all angles here. Sum of all is going to be, there's 5 of them. So this is 5 times 108 degrees, which is going to be equal to, again, this is noteworthy. Okay, don't sweat. It's NBT, this thing. So 5 times 8 is 40. 5 times 0 is 0 plus 4 is 4. 5 times 1 is 5. A1 is 540. So that means the sum of the angles in a pentagon must all add up to 540 degrees. Please no west these things. No west thou these things. A1. Now folks, ndicela wena mntwana isikolo explore other polygons. Now we want to draw some conclusions. The reason ndizenze kanje ezinto ndifuna uzibone ukuba kukhona something here. If you notice these, for those who know the things, if you know the sum of these angles are multiples of 180, can you see? 3 angles 180, 4 angles 360, that's double 180. Pentagon, it goes to 540, that's 180 by 3, is it not? Asiqale futhi 10. When these are 3, we get 180. Ne? We get 180. So this means the sum of angles here is going to be what? If we compare this to the number of sides, you can see that this is 180 times 1. So from 3, so this is nothing but 180 degrees. So this is 180 degrees times 1, literally, because it's just 180. So if it is times 1 from 3 sides, if we can express 1 smartly, so this is 180 degrees into this is 3 sides, then we subtract 2 to get 1. So if we then take back the sides, we say it can be any number. We can say this is n minus 2. Now we can see that if we wanted the sum of these by using the sides, and we know that this is a multiple of 180, so please just know these are going to be multiples of 180. So multiples of 180, so this is going to be the story, right? So the sum of angles is like this. So from the sides we subtract 2 and then multiply by 180. Let's look here, what's cooking? So here again we know that the sum of angles here is going to be some multiple of 180 into, let's see, this became 360, so this was 180 times 2, but now we had 4 sides. So you can already see this is 180 into 2 can be gotten from 4 minus 2. But there has to be a consistent subtraction also. So again, we can replace 4 with n because that's the number of sides of the polygon minus 2. And we can see that this indeed will always work. So folks, the thing is, these are all multiples of 180 such that we say the number of sides of the polygon minus 2. Okay, all right, okay. So this is how we find the sum of angles in a polygon. If we go to the last one, just to complete our exploration. So we can say, therefore, here the sum of angles, it's a multiple of 180, right? Because this divides 180. without a thing, right? So 180 times 3, let's just check it. So this is 0, this is 24, carry the 2, 3 plus 2, that's 5. Can you see it's 180 by 3? So this is 180 into 3. Now this is going to be 180 degrees into 3 from 5 is 5 minus 2. Can you see consistently? So this is 180 degrees into n minus 2. So this is how we find the sum of angles in a regular polygon. So basically it's always going to be 180 multiplied by the number of sides minus 2. We will always get the sum of the angles. Okay, all right, okay. And obviously, folks, if we want an individual angle, we're going to divide that by the number of the sides as well, right? So that's just the story here. So that's just the one thing that we can do. So obviously, now let's make some conclusions. So now in conclusion, remember, guys, you don't need to be taught everything. Other things you can study, use your knowledge and find out things, even in the exam. Sometimes think about those, but of course, you need to know basics about these things, as I said. If you know what a regular polygon is by definition. So we can just say in number 1, a regular polygon has all sides and all angles equal. That's number 1. Number 2, a regular polygon has a circumscribed circle. Or simply put, it is inscribed in a circle. Right, so it's either you say there's a circumscribed circle or it is inscribed in a circle. 3, the angles, or let's just say each angle, is going to be equal to the multiple of 180 to n minus 2. Then we divide by the number of sides, because we can see that if the sum is like that, then when we divide it, because they are equal, it's going to give us each angle. Number 4, the sum of all angles is equal to 180 degrees multiplied by n minus 2. So you take the number of the sides, you subtract 2, you multiply by 180, it gives us that. So this means, guys, any given regular polygon, you can use this knowledge. So I wanted to help you guys find things out. Ngokwenu ngoba if usiyaniteketisa sinidlise nestam, nizoba ngabantwana badom. Abantwana benestam badom. Ezidla inembe, niyazi inembe. Umntwana omncane ubele ne kunini. Nodla ukudla okunatural masayekwazi ukutya like inembe yonke lanto angatyi nestam, namabhiskiti namalopisi. Lo mntana lo ba uyakhalipha apha engqondweni, uyazinza. emotional akabhabhazeli akasasidenge. But abantwana abadla inestam baya-constipate, baba nee-issues zamathumbu, issues ze-weight, yonke le nto le bayakhawatheka. So ungakulinga udlisa umntwana udode. Udlisa umntwana udode uzoba dom, ndikuxelele. And maseke ngaboni next uzamane ukhala umntwana makanalax soka umhlisa umnyakanyaka ucimba uzoba clever xa kutheni lo mntwana. Ukwazi utyisa umntwana odode inyakanyaka bese ucingela uba yena akazi uba yinyakanyaka. Kodwa ke bantwana bakuthi, there are some special kids. No matter what you feed them, God decided their brains are just going to work best. Okay, feed loo nto nayo, kodwa ke you're going to have to work to bring up that person into an individual that you can work. All right, guys, so this is to say all regular polygons work like this. You see this conclusion? I showed you how, we work it out nicely. So, of course, the long way is this way, using Euclidean geometry principles. But then from there, we can derive some shorthand techniques like this one. So this is actually the essence of observation or inspection of what is going on here. How are these things related to this and this? Because at the end of the day, you don't have to suffer from scratch each time. Yes, the first time when you explore an idea, you have to take it from its basic principles, bring it up. Once you get there, look at the pattern. From the pattern, you derive some shorthand techniques, because at the end of the day, we want to solve problems much faster without flinching. But we don't start there. That's the end of all the process and the struggle. And if you don't struggle, you're not going to be good, because when this doesn't work, you're not going to see it. Because wow, nina nivele nibe zinkomo ezifakwe DP. Niyangena noba sekuyingozi egameni loba bangenile abanye nathi siyangena lo mkani ke ne. Be vaker voor man. All right, folks, that's what I wanted to show you. Now let's just take some 2 questions and just explore the idea of this so that you can see it in practice. Right, folks, so I found this. Remember, this is from the booklet that I sent you already, the Oli Core Dondons. So let's try to practice using this knowledge on such stuff. So we're going to take this question 41 from Oli Core booklet. Right. So if you don't have it, go and find it. But all I know is that it is in the description of the other NBT videos that I showed you. But hey, I would be nice. Check the description of this video. You will find all the stuff that you may need. Okay. Then use it wisely, or suffer the consequences of being ignorant. That says a regular octagon. You see this? The word regular must come up. Otherwise, you don't use what I told you just now. Is formed as shown, okay, not drawn to scale, with A at 0 and 4. Right? So basically, this is to say if this is the origin, so this is at 4. Now B is 0 and 4 as well. Sorry, it's 4 and 0. So this is 4 with the origin at 0. Okay. But now what do we know, folks? This side is equal to that side, equal to that side, equal to that side. Ewe, injalo kaloku. It's like this. So please know these things, bafethu. So all the sides are equal because it's a regular octagon. Excuse me. Now it says find the y-intercept of the line EF. So this thing is the 1. So we want to find the y-intercept, and of course we will find the y-intercept from working on the equation. So obviously we need AB, right? Because that's the distance each is each. So we first need the distance AB to find some things that we need. But now, does it help us at all? Yes, it will help us to locate what are the coordinates of E and F. So let's try to use this. We know that AB is going to be the square root using the distance formula. X at B, that's 4 minus that 1, 0 plus. This is going to be Y at B, which is 0, minus Y at A, that's 4 all squared. So AB is going to be 16 plus 16 is 32. So this is square root 32. Now 32 is 4 times 8. Right, but now I say root 2 in here. If we know root 2, so it's 16 times 2, yeah. So therefore AB is going to be 16. This is 4 root 2 units. Okay. Dwelling has one balance on sometimes. Okay, so that's the first thing. So now, folks, if this is the case, now this is 4 root 2. So this means from 4, we add 4 root 2. That means the y value there is going to be 8 root 2, right? Am I correct? No, not correct. So the y value there is going to be, look, it's going to be 4 plus that distance of 4 root 2. So this is just going to be 4 plus 4 root 2. Now can you see this G is in the same level as F? So that means the y value here, okay, it looks like we're going to have to change a bit. So this is 4 plus 4 root 2. So that's the y value at F. At least that's how high it goes. Okay. Alright, okay. Now, man, at H, man, yewena sunkhatha, man, sunkhatha. Ngichatha njengesele, man, ngichatha ngekhuni. This one is the y value at H, guys. Yo. This one is here. Yo. boy. Yeah. So that is the one. So this means that's the y value at E. Okay, they must be in the same level, seeing that it's seated on the ground. So this is 4 plus 4 root 2. That's the y value at C. Now let's find out what would be the x value there. Well, can you see this one has gone 4 units from 0 to B. And then the distance is going to be 4 root 2. And then again another 4 units. Because the way it moved from the origin is going to be the same distance over there. So we know that the x coordinate at E is going to be 4 plus 4, that's 8 plus 4. So this is going to be 8 plus 4 root 2. Okay, so that's how things work out here. Okay, now we've got the full coordinates of E. All right, now let's have a look. We know without a shadow of doubt that this line must be parallel to that one. this is a regular polygon. So if it is placed like that, those lines must be parallel. Okay, so this means we just need the gradient of AB. It's going to give us the gradient of FE. So analytical geometry with a regular polygon. So we know that also the gradient of EF, right, is equal to the gradient of AB. These are parallel lines. Nice and easy. Now this implies that the gradient of EF is equal to, now let's check, this is going to be 4 minus 0 divided by 0 minus 4. So we know that this means the gradient of EF is equal to minus 1. That's all right. We can say then EF as that line is going to be y is equal to minus x plus c. Now through the point E, which is 8 plus 4 root 2 is 2, 4 plus 4 root 2. This means 4 plus 4 root 2 is equal to minus into 8 plus 4 root 2 plus c. 4 plus 4 root 2 is going to be minus 8 minus 4 root 2 plus c. Therefore, c is going to be, now if we move this around, it's going to be 8. 8 plus 4 is going to give us 12. Now 4 root 2 times 2 is going to be plus 8 root 2. So the answer is C. Sharp, sharp. Sharp, sharp. So that's basically how we get our business sorted here. As you can see, it takes noticing certain things, like the issue of certain parts in an octagon are always parallel to each other. All sections that are just directly opposite each other, they are certainly parallel to each other. So work with these, folks, as best as you can, and try to realize other things as you see them, because you will not be primed beforehand, but a few issues will help to move you around. Okay, folks, that is the question that I needed us to have a look at. So the second question I want us to explore is question 39. This is question 39, again on our Olico. You will find it in the description below. So again, the diagram shows a regular polygon. Please, this statement has to be given, or some property of it will be highlighted. Then you can apply the principles. Now we need to find the angle theta. Okay, so we can see that this is an angle subtended by this section. But what do we know about a regular polygon? We know that there is a circumscribed circle. So there's a circle there doing things. So that property of having a circle around. Now with any circle, there's a center. Right? So there's a center somewhere. Whether it's inside or not, now we can do the things. We can do the things. So we can see that, let's call this center O. Now you can already see, guys, our job is just to find the angle at center. Once we find the angle at center, we know that theta is the angle at circumference. So we are sorted. Can you see? Very easy. Now we're going to use the shorthand techniques that I've shown you so that you understand what's cooking, because sometimes you don't want to struggle. So we know that what would be the value of the angle at center? Or, what would be the angle at center? I think for this one, we need that, because that theta is not necessarily related to the corner angles per se, or the sum of angles. Right, so knowing that these chords are all going to subtend equal angles at the center like this. Remember, these are all these all become the chords. So that means this angle must be the same as that and that and that. So if there's 8 corners, obviously there's going to be 8 angles. So 1, 2, 3, 4, 5, 6, 7, 8. So there's going to be 8 angles in there. All right, so let's find the angle at center. So we know that angle at center is going to be equal to 360 divided by 8. Or perhaps let's say let the angle at center be x. So such that we know that 8x, because if there's 8 sides to the polygon, there's going to be 8 angles subtended at the center. Right, so 8x is equal to 360 degrees. Again, this is the revolution. Now this means x is 360 divided by 8. Again, just do your job, folks. Don't panic. There's no shame in just looking up things. 8 to 36 goes how many times? To 34 goes 4 times. 4 times 8 is 34. Minus 6, this is 2. This is 0. We drop the 0 there. 8 to... Itheni ngathi ufuna ngiphambanela nje. Ekasenkere byalo man. Ubani othe i-octagon lo? Ya, kodwa zi-8 njena. 1, asiqala apha. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not octagon, but it's non-9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh Lord, Z9. Okay. The reason I'm skeptical is because this is not going to work nicely. All right, so this is 9, so all of this is gone. 9 to 36 goes 4 times. So this is 36. 0, we get this one, 40. So this is 0, so this means our x is going to be 40 degrees. We can say then theta is going to be half of 40. We know that angle at center is equal to 2 times angle at circumference. Okay. I'm tired, guys, so therefore theta is going to be 20 degrees. The answer is option B. Right. Therefore, our answer there is B. So we used the property of having a circle around every regular polygon. That's the knowledge we need to keep in mind. Can you see just one of the properties? And of course, knowing how to use our Euclidean geometry, that equal chords will subtend equal angles at center. If the chords are 8, then there will be 8 angles at the center that are equal, which will form a revolution. If there's 9, like in this case, which I failed to calculate how many. I used the previous question and I got myself in trouble. So obviously make sure, guys, you inspect before you work. Okay. Right. So this is it, folks. I hope you've enjoyed the video and that you have learned all that is necessary, because I think this is what was the missing piece to most of what we were supposed to do. So folks, good luck with your NBTs. And please, I can tell you, recycle as many of these questions. When I say recycle, do them over and over again. Do the questions in this booklet over and over again, okay? Just take a day, work through all of these problems in this booklet. Take all the tests or the test samples and do them, okay? Just spare a day, do this thing. Where you struggle, skip. Don't stay there. You skip. You go through as many problems as you can. Then you mark those ones that gave you a problem. You go and have a look at them after you've taken a break, maybe some lunch or whatever. Go back to those questions. Now you're going to sit and look at them in the eyes. They must look at you back, and you don't blink. And it's not going to blink also. And then you're just going to tell it that, look here, when if you don't break, I'm going to break it so bad. It starts breaking all by itself from your inspection. All I'm trying to tell you is that inspection is your best tool. You look at the problem, you think of what you know, you look at the options given, you think of what it may suggest. You will probably have an idea of how to go around those problems. Yes, some with difficulty. Trial and error is going to be part of the game, unfortunately. And be capable of just plunging yourself into the deep end and just swim across. Right? If the current is too heavy, use the current to move you to the edge. Don't fight it. You're going to get tired. All right. Yeah, folks. You will find everything in the description of this video. The booklets to practice the tests for your NBTs, be it the QL or the MAT. You will find the document that I took these sample questions that were the bulk of this video in the previous one. I think those are good questions that certainly do push you to the limit a bit. And if you can keep up, surely you're going to ace that exam. Remember, folks, I will say this again. The intention of this video is not to give you the questions that are coming in your NBT, okay? Please, yes, you might be lucky. That's the advantage of being prepared. There's nothing wrong if you get these questions, even if it's all these questions instead of others. There's nothing wrong with that, because you have worked through these and understood. You will be able to keep time and get those answers. But remember, guys, always feel glorious and better when you have worked through the problems using your knowledge, your understanding, and your flexing of the skills in maths. If you don't have the gymnastics, please start practicing now, okay? There is no amount of questions I can do that will prepare you. I can only help others who are lucky to copy, because technically if you get the same exam, it's more like copying, isn't it? But it's not a crime if you have worked through those problems without the knowledge that they're going to come. At the same time, you have applied your mind in those, exams. So what is best, folks? Every time you see a question, pause the thing, attempt the question, then watch the video as I solve it. You will see I get into a struggle too. Sometimes you have to skip, so don't be too stubborn to hold on to a question. Just skip sometimes. You will see when you come back, you'll have a better game. See, one of the last few questions gave me a headache, but just, escaping that problem, trying to not have my mind locked into it and end up lost altogether for the exam. You sometimes unlock your vigor by killing the next question within reasonable time, and then you go back and see if you cannot use that extra time that you would have spent trying to study the next question, then you use it to then unlock what could be missing for the other questions. Otherwise, folks, in the end, it depends on what you are capable of doing to move forward. If you're not capable, then please leave us alone. Don't do maths, okay? But if you are willing to struggle, trust me, you will never master maths if you don't struggle with it. If you get stuck and you need a solution from somebody else, then just worry about yourself. Maths is going to give you problems. This is not the subject of people who are normal, okay? You need to be abnormal first. Yes, you can change from being normal to abnormal. You see, normal people don't want to struggle, but abnormal people enjoy the struggle because they know at the end of the struggle, there's big, 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 big rewards. Being normal, you live less, you gain less, okay? You struggle less, you gain nothing. You will always be wondering how things happen for others. They sweat, they don't sleep, they don't rest. Sometimes they struggle, they cry, they want to give up, but then they come back and try again and again and again. So that's just life, guys, and life humbles everybody in many ways than you can imagine. Sometimes don't be thrilled by what you see as the so-called success. It's actually a false representation of what success is. Success is not graduating. It's not getting that dream job of yours. Success is far more complicated than people can describe in words that a person can understand. It's sort of like a mixture of, practicality of something. Its existence, of course, has to be there, but it's more than just its existence. Look, I can train you to become as good as you can be in the subject, but you may not achieve much success in the subject on your own. So success is very complex. So guys, just make sure that you are the success in this thing so that you attain some sort of independence. What I'm showing you must fuel your curiosity. It must make you more aware. It must make you to hunger more. Even become creative. Start becoming creative. Take this very question you see before us. Twist it in as many ways as you can imagine. You will see some tweaks that you can give would technically be incorrect under certain circumstances, in which case you'll start to realize how far you can go with this knowledge and when are the limitations going to show up. What indicates a limitation in this regard? Things like that. Because this is when you have fully gone through all the basics and you're feeling comfortable. You've done your groundwork. You're comfortable with it. You can play around this without any issues whatsoever. No stress, no pain. Even when you lose a particular question, you're not going to cry because come on, it's one of those. Sometimes your mind is not at the right frame of thought as necessary for a particular question, as you can see also with me. But then, if you just keep your composure, you maintain your focus, you concentrate, and you have that heart for the thing, you'll just keep going. Look at the girls when you try to introduce yourself. You tell this one, hey, come here, man, I want to talk to you. The thing tells you, hey, one, that's a lot. Goes John, Pindon John, when I come John, Tita na anda banje ngawo. Oh, ezaweza nduxelela baze ungazimamela ungahlanye. Ungazihoyisa uze nala confidence hayi wena seniphambanela. Zapha man. Thukise la way uyishiye. Ungabi too much uyishiye. Phinda udibane naye futhi mayevenkela phinde block ye wena. Benzama uthetha nawe apha izolo ufuna uthini bo. Phinde xhuma ngabe la way iyeke ivayo. Uzobona i-registration leyo kulaa ngqondo. Nawe qala ufunde ngokuba xa unguwe uzomxina kanjani lo mntu. Thina ke ngosasakhula sasinala pride yoba sizomxina ngamagama, yabo. We used words. There was a thing for the words, Even things as unlikely as just convincing someone to to be your significant other. We used words as a way of trapping them, and they actually got trapped multiple times. So you see, you become patient, but you keep escalating your level of engagement and, attack up until you win. And when you win, it looks as if it never happened that you got insulted. That's how maths works as well, folks. It's going to insult you big time. It's going to tell you you're wasting your time studying, attending classes, and not sleeping, practicing, and you go and fail dismally sometimes. That's just the way you grow in the subject. That's the way you become better, because you will start to notice more than you would be shown if it was easy to proceed with a particular issue. So ready-made stuff, guys, doesn't teach anybody anything. But the struggle, yeah, that's why you see me do these videos first time, first hand in front of you, and struggle and shame myself so that you can see that I don't always have it figured out immediately. Sometimes it takes a moment to get around things. And certainly others I cannot solve. I mean, I'm not the computer. Certain things are created by the computer using the least, let me not say the least, but things that you would not think about normally or under normal circumstances. Just small little details. Hence, I say, spend time with as much detail as possible, even when it's not necessary to consider those details. You will see how those things are going to reward you. Otherwise, guys, please get a distinction truly from your understanding, not some pure lack of getting questions that you saw or, okay, let me say, do not rely on seeing what you've done or seeing something similar to what you've done. Just enjoy exploring things even the first time and achieve maximum success, because that means you are set up for life. Nothing will ever confuse you to the extent of you failing. You will see when you get to varsity, it's not as easy as in matric. At the same time, the exam questions are not really that far-fetched, by the way. You don't get the type of higher grade questions you get in high school. Let me just say, for the level of study, of course, you really don't get those higher grade type questions there. But trust me, even a simple question can turn up ugly if you don't do your work. And as you do it, you don't have a clear understanding. And I can hear a lot of people saying, don't understand, just know the drill. No, man, it's not going to work best for you. It's just not. There's people who pass cum laude. They get to work. You get stuck there and you'll be ashamed. You come with those credentials and then you fail. You're already tarnishing the idea that people who come with good results are going to be good enough for a particular job. So please don't do this. Don't pass very well using your past exam papers and whatever. Get cum laude, because obviously there can only be a handful of questions that can be asked, because even those examiners at varsity don't have time, guys. I mean, look at the medicine class. When we started, we were like 200. Yeah. We were 200. Can you imagine marking scripts that are of higher order, lots of questions, difficult stuff, and everybody trying out their best? I mean, there's no time for such. So as a result, the exams are somewhat toned down. But the nice thing about it is that you don't know what is going to come out, because you've got this huge textbook with 5 topics. Each chapter has about 37 to 50 pages. Complex stuff that sometimes half of which you don't really understand, no matter how many times you go through it. And then they bring in that one that you didn't understand, but it's actually as basic as in the textbook. It's never really beyond the level of the textbook. Maybe 1 or 2 common topics that are probably easy to understand. Then they can be moved up a notch higher, because we certainly cannot just spoon feed you there. But even when they do, it's not going to be to a level of maybe level 4 or something. Maybe you can say it ends at 3 if it ever got very hard. Even then, you will see that it's going to be topics that are well understood. So it's your job to make sure you level up. Okay. But anyway, folks, before I preach and never stop and start to not make sense, talking gibberish, good luck with your life, your futures. I have taught you everything. We have finished the syllabus during our tutorials. Now, when you come back from your holidays, in fact, some of you need to work with me during the holidays to start revisions. So with us now in our group, we are doing revisions for the trials. And this time, guys, we're going to start looking at those silly questions, you know, how to strategize and how to work things out, because we've done the groundwork. If you don't know it, it's your problem. I'm sorry. But if you have been keeping up with the groundwork, you will see and appreciate it. Please continue to work on it if you find a shaky ground on your part. But of course, guys, I'm comprehensive in our classes, so I don't necessarily focus on higher order questions. I still do bring in the basics every now and then. I answer every question that a student has, whether smart or not, if you think so. But in my opinion, there is never a bad question, even one that on the face value looks a bit ridiculous. But that question, you will be surprised of how much wealth is in it. Some misconceptions get dispelled by just a lousy question according to, you know, some standards people set for, you know, categorizing questions. In my opinion, anything that's a burning question in someone's mind, it's something to clear. All right, folks, good luck again. And please learn as much as you can. The channel has lots of videos, over 200 videos. And these videos, guys, provide you detailed answers to questions. Even when I make a mistake, you'll be able to see, because everything is clear. I don't try to, you know, manipulate you guys to thinking I know it all. My faults, I don't try to hide them in any case. That's why my videos are longer, because I need you guys to see what I do to survive in the subject. Despite having learned the basics and understood them, I still have to strategize, and sometimes successfully, sometimes not. So this is exactly that journey. So maths is not something you can think you know it. You just hope it doesn't get too messy. All right, folks, have a good one. I'll see you in our classes tonight. Life Sciences, here we come. Sharp, sharp. Don't be late, 7:30. Okay, guys. Bye.